All right, hello everyone and welcome. Glad to finally be in the same room as all of you for the first time this semester. I know it's been a wild ride for me, so I appreciate your patience to deal with the ice and then me getting horribly sick for a while. Very happy to be back. Very happy to see you all here, and hopefully we don't have any more wild, crazy stuff happen. At least for this class this semester. Fingers crossed. I hope all of you are also healthy and getting through the semester okay. I think it's a good time to just remind you all that yes, life happens outside of this class, and this class is not as important as your health, either physical or mental or otherwise. So if you find yourself in a position like me where you get really sick and can't do any work for a few days and can't get out of bed for a few days, I don't want you to panic about this class. Yes, we have course policies in place. We have things like late coupons, and we allow you to drop certain things if you aren't able to attend class. But even if you exhaust all of those resources and you're still in trouble, I hope that you come talk to me. I don't want to make any promises. It all depends on the specific situation. But I want you all to know that I am willing to work with you. I am going to ask you to follow the course policies first. But if you run out of late coupons, don't freak out. Come talk to me. We can have a conversation about it. Try and figure out a way to make sure that you're able to get the work in on time. Due dates and deadlines and things like that are not the reasons why I want to give people, actually I don't want to give people bad grades in this class at all, but I definitely don't want to do it just because of deadlines and stuff like that. I want your grade to be based on your knowledge of the course materials. So please come talk to me if you find yourself sick or unable to attend class for any reason. Yeah, and I will try to be just as flexible with you as you were with me as I was going through that stuff over the past week. I really appreciate it. Something else I wanted to make sure that you're aware of. I'm not going to spend a whole lot of time talking about it today. I just want to make sure you're aware of it because it is coming up. Our first exam is next week. So 1 week from Thursday is our first exam. It is in the evening. So it starts at 6:30 p.m. on Thursday next week, the 15th. You can see some information about the exam here. I'm not going to go over that right now. However, 1 week from today, on Monday, I would be very happy to go over this information with you. That's going to be our exam review day. So when you come back to class next week, 2:30, exactly 1 week from today, I will be up here ready to talk to you about exam 1, ready to talk to you about the kinds of stuff that's going to be on the exam, ready to go over some practice problems, stuff that's going to be on the exam. And if you want to start looking at that stuff now, I would like for you to know that I do have exam prep materials on Canvas. I've got 2 different sets. This one that's past exam questions. That's a practice quiz that is literally past exam questions, hundreds of them from past exams that you can work through. But those are all multiple choice, true, false, fill in the blank style questions. And then there's also coding prep. So for coding style problems, these are also ripped directly from past exams. I'm trying to give you as much examples of exam stuff as I possibly can. In fact, when I go home tonight, I'm going to add the questions from last semester's exam into the question pool. So you'll see all of those. I try to keep all of those up to date. Every time I write an exam, they get added to the question pool as practice for the next group of people. So that's all there for you. Take a look at that now. And the one other thing I want to make sure that people are aware of it in case they need to be aware of it is that if you require accommodations, then you will need to take the exam at Disability Resources. I know this doesn't apply to everybody, but we do not have the ability to provide for accommodations in the main exam rooms. So if you need accommodations for the exam, please reach out to Disability Resources as soon as possible. They do like to have, I believe, at least a week's notice, so you still have time. The week would be on Thursday. But definitely get in touch with them. I have had students unable to use their accommodations in the past just because they didn't reach out to Disability Resources ahead of time. You cannot show up on the day of the exam. They will not let you in unless they know you're coming. So I'm trying to give you advance notice of that in case you need to contact them for any reason. Yeah, I'm not going to go deep into exam stuff. As I said, we'll spend class time on Monday going into exam stuff. But does anybody have any logistical questions right now before I hop into today's topic about stuff that's coming up? All right, fantastic. then let's go ahead and switch over and start talking about coding. And I actually want to start today by congratulating all of you on a very momentous achievement. I know we're only a few weeks into the semester, but I have some very important news to share with you all, which is that even though we're only 2 weeks in, I've shown you 2 topics. I've shown you variables, types, and I've also shown you loops and if statements, right? With those constructs, variables, loops, if statements, you can write any program that is possible to be written. Any program at all. So we're done here, right? You can all go home now? If only, if only, if only, if only. What are we doing here? If what I am saying is true, and you can literally write any computer program that you want to with just loops, if statements, and variables, then what the heck are we doing here? Well, think about the programs you use on a regular basis. Think about your browser, your web browser, or even the websites that you visit on a regular basis, right? TikTok and things like that. Could you write those kinds of programs using just if statements, loops, and variables? Yes, yes. As I said, any program that is possible to be written can be written with just those building blocks. It would not be fun. It would be very painful. It would hurt. I would not want to do it. It would not be a very enjoyable experience. The code would be very long, very hard to understand, very fragile. So while yes, those basic building blocks are all you need, there are other building blocks that make it a heck of a lot easier for us to write programs and talk about programs. And that's really what computer science is about, right? We've figured out how to make our computers do our bidding a long time ago with the very first computer. We're not really doing much different now. We're just doing it a whole lot faster and a whole lot more efficiently. We've gotten better at talking to the computer. In the past, it used to be all zeros and ones. Now we have languages. Now we have computers talking to us. It's kind of wild, right? That's the future of programming. So, what we're going to spend the rest of this semester talking about, and actually if you go on to take more computer science classes, you're going to learn that we're not going to stop writing loops or if statements. Those things aren't going anywhere. But we're going to add a lot more tools to your toolbox that make writing programs even easier for us as human beings to make the code that we write go a long way. So that's kind of where we're at right now. And today's topic is actually a pretty good example of a nice tool for us that, while we don't strictly need it, makes our lives a lot easier. What we're going to be talking about today is arrays. And arrays are our first example of a collection of data. So up until this point, we've had the ability to make variables. Variables represent a single piece of data, right? A single integer, a single double value or single string. But consider that, while that's certainly valuable and I can create as many of them as I want, it is oftentimes useful for me to have a collection of data and be able to refer to multiple values as one set of data. So to consider a very classic example, let's talk about the weather. Let's say I wanted to do some weather analysis, and I'm going to start by picking some of the easier metrics, and I'm just going to take try to find the high temperature every day and write it down and then do some data analysis on that over time. That's a pretty basic, straightforward thing to do. If I wanted to do that for a week, then I could start by saying high temp day 1 equals 55, high temp day 2 equals 54, high temp day 3 equals 50, and just record the temperatures. But consider that if I wanted to do that for a month or a year or 10 years, how many variables would that then require? More than I'm willing to sit here and type, right? Honestly, if it goes longer than a week, that's probably too much for me. I'm just like, nope, not going to do it. That's too many variables. I don't want to make all those variables. I would rather have one variable that represents the entire collection and manipulate that collection. And that's where arrays come in. Arrays represent not just one value, but a collection of values. And typically, of course, those values are going to be associated with each other in some way. They're going to have, they're going to have some sort of relationship. It's not just random values that I'm throwing in there. This is not the only collection we're going to see. I'll show you some other examples of collections later on, but this is definitely one that we're going to be using a lot. And so let's take a look at some of the basics. If I want to create an array, it's actually not that much unlike creating any other variable. The biggest difference we can actually see right from the get-go. If I was just creating an integer, then it would look like this. But those square brackets, those are a dead giveaway that I'm talking about a collection. I'm talking about an array. In fact, when I see this given as a type, my brain has been trained to immediately think integer array. Right? That's what my brain thinks when I see that, not int square bracket bracket. It says int array, because that square bracket's just been drilled into my brain as meaning arrays. And I hope that your brain starts to get trained that way as well. So I am creating not just one integer, but a collection of integers, an array of integers. This is just the name. It's called high scores. And then over here, I've actually seen this new keyword before. Anybody remember where we've seen that before? Scanner. Yeah, we've seen it with scanner. Here we're seeing it used with something that's not scanner. We're going to see it pop up a few other places as well. But here we see that new keyword again. And then I'm creating a brand new integer array, and I'm saying that it has 10 values in it. That's what the 10 represents. The 10 is the size of the array. And when this statement gets executed, what I actually have is a collection. The book, I believe, talks about it as like a line of lockers, or I often refer to them as buckets, right? I now have an array that has 10 buckets in it. Okay, and so if I want to create more arrays, I can. Notice that whenever I create an array, it's not enough just to say that I'm creating an array. There's a type associated with that array. So if I want to create this array of 5 doubles called prices, okay, that's how I would make one double. I put the brackets on the end, and now I'm saying that I'm making an array of doubles, a collection of doubles, called prices, and that's going to equal new double. And it only wanted 5 of them, and only wanted 5 doubles this time, so I'll just put a 5 in the square bracket instead of 10, right? Let's put a 5 in there. It tells me that there's 5 buckets in this array. And then I'll do that one more time, this time with strings. String array names equals new string 5. Okay? All of these are just creating empty arrays, empty collections with empty buckets. Now, I say empty, that's maybe a little bit misleading. The buckets have values in to start. They have what we would call default values in to start. So here I'm creating an array that has 10 buckets, but I haven't said what I want any of the buckets to hold. There's nothing in here that says, you know, put 7 in this bucket, put 2 in this bucket, right? We're getting there, but we're not there yet. So if I were to look at this array right now, it would just have 10 zeros in it. 0 is the default value for integer arrays. 0 is also the default value for double arrays. So if I looked at this array right now, it would just have 5 zeros in it. That's probably not what I want. Probably want to actually fill it with some information. But those are the default values that I would expect to see in the array. For a string, it would have what's called the empty string. Just quote, quote by itself, nothing in the middle. Those are the default values. That when you hear me say an empty array, that's what I mean. An array with nothing in it, all zeros, all empties, right? And then finally, for this example, we see that I can ask an array how big it is. And you might be saying, well, that's a little silly. Why would you do that? It's 10 or it's 5. I can see it right there. Well, consider that it's possible that I don't know how big this array is. What if somebody else made that array and gave it to me? Then I don't know how big it is. I didn't make it, right? It came from somewhere else. It came from the outside world somehow. I need to ask how big it is. I need to ask how many elements are in that array. So we can do that by using dot length. If I type the name of the array followed by dot length, it will tell me how many values that array can hold, how many values are in that array. So if I run this, you see, all right, high scores was declared with size 10. I can change this value, right? If I change it to, say, 6. So now high scores has a length of 6, and when I ask for high scores.length, it'll say 6. So I change the size up here, and it correctly reflects that change when it asks for the length down here. Again, this is useful because I may not know. If I didn't create this array, I may not know how big it is. So I might have to ask. I might have to ask that question. Or what if the size of this array changes? That's another thing. But that's also something that we need to keep in mind. Once I create this array in this code as size 6, it is forever size 6 until the program is over. So what that means is I can't come down here later and say, this is not a valid statement. In other words, I cannot assign the value of 10 to the length of the array. That's not possible. That's not allowed. I cannot change the size of that array after it's been created. Once I've created that array of size 6, that's what it is until the program's over. That's what it is until the program stops running. I cannot change it after the fact. I can ask what it is, but I can't change it. Turns out to be a kind of a frustrating restriction, but one that we're going to live with for quite some time, as a matter of fact. Okay, let's talk about how we can actually get some data in here, because so far right now I've just created 3 empty arrays with just default values, nothing in them. That's not very useful for us. So let's talk about how we can get some data into the arrays. There's actually 2 different ways. 2 different ways. If I know what I want the data to be when I'm creating the array, then I can say that. And the way to do that is with this curly bracket syntax. So here, I'm actually listing the contents that I want to be in that array. This array, when created, will have 1, 2, 3, 4. It'll have a length of 5 because there are 5 values in here. And the 5 values will be these 5 values right here, in this order, in this exact order as they appear. So if I run this code, it'll create the array with those 5 values, and if I ask how big it is, it'll tell me the length is 5, right? This is actually a good chance to show you how convenient it is to do stuff like this, because if let's say I want to come back in and add more values later, right? The computer is smart enough, it'll say, all right, you've now given me 1, 2, 3, 4, 5, 6, 7, 8 values. So now I'm going to create an array with size 8. And when you ask me when the length of this array is now, I'm going to tell you that it's got a size of 8. So it automatically is adjusting based on the data that I put in here. That's nice. That's convenient. The other way that we can do it, let's say I don't know what I want to contain, what data I want to be in this array. Or, to be a little bit more specific, let's say that I'm going to ask somebody else to tell me what they want to be in this array, right? I could use scanner to ask somebody to type in numbers and then put them in this array. How would I do that? How would I actually take values that come in after the fact and place them into my collection? In order to do that, we have to understand that every single value in an array has an address. So if I'm looking at my array as a series of values, right, every single one of these values has an address, or the computer science term for that is index. Every one of these values has an index. The value 99, we would, as humans, say that is the first value in the array, but the address, the index, is actually 0. The number, the index assigned to that bucket is 0. The index of the first value in an array is always going to be 0. As computer scientists, we do not start counting from 1. We start counting from 0. Always, 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 always. So the 99 is at position 0. The 98 is at position 1, right? The 75 is at position 2, and so on and so forth. Think about the implications of that. I have 5 things in my array. There are 5 buckets, right? Bucket 0, bucket 1, bucket 2, bucket 3, bucket 4. There is no bucket 5. There are 5 buckets, but there is no bucket 5. because we count from 0, not 1. It's very important. Very, very, very important. In fact, we can generalize that. If I have 10 things, okay, 10 things in my array, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is no bucket 10. I have 10 things in the array. The index of the last bucket is 1 less than that. And that will always be true. If I have x things in my array, the last index is x minus 1. Always, 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 always. And again, the reason for that is because we start counting from 0. Start counting from 0. Questions? That's an important fact, one that's going to come up again and again and again. What does that mean for us right now? We'll take a look at what we're going to do in this array 3 example. I'm creating an empty array with 5 elements. Here I'm showing you what the default value is. So if I run this program, it'll say 0 up front because that's the default value. I just created the array. I have not put anything into it yet. There's nothing in the buckets. It's empty. So it's just filled with zeros, and I see the 0 that gets printed out there. Okay, how do I put something into those buckets? Well, it's a variable assignment statement. So like my other variable assignment statements, I'm going to read it from right to left. I'm going to take the value on the right-hand side of the equal sign and stick it in the variable on the left. The big difference now is that this variable is a collection. High scores is not one value. It is a collection of values. So in order for me to assign something to it, I have to give you an address. I have to give you an index. Which bucket is this value going into? So I'm saying take the value of 99 and put it in bucket 0. Take the value of 98 and put it in bucket number 1. Take the value of 98 and put it in bucket number 2. We're using the square bracket syntax to specify which index, which bucket, which address we are currently working with. So these statements here will fill the array with data. And then if I want to get the data back out, I can use that same square bracket syntax. So you can see here I say print out high scores of 0. I'm printing it out twice. Once before I fill it with values and once after I fill it with values. Before I fill it with values, it's all zeros. After I fill it up with these values, you can see that the value at bucket number 0 is 99. If I switch this to print out the value at bucket number 3, I hope I get this, right? Because I'm very clearly saying take the value of 88, put it in bucket number 3. So if I say tell me what value is in bucket number 3, I hope it's that 88. And there it is, right? Okay. This is all doable. However, I would argue that putting the number 3 in brackets like this, or even this, 0, 1, 2, 3, 4, putting a specific address like this inside of an array is dangerous. I would argue it's dangerous. I would argue that you should avoid doing things this way. It's okay for learning, right? For learning how to access arrays and what the different addresses are. But in practice, we need to be very careful about what numbers we put in here. Consider, for example, what if I asked it to print out the value at bucket number 7? What's the problem? How many buckets do I have? I have 5. There is no bucket 7. Bucket 7 does not exist. So anytime that I am putting a number directly inside of those brackets, I'm running the risk of this. I'm running the risk of getting an array index out of bounds exception. I can almost guarantee you're going to see this error at some point this semester if you have not seen it already. It's a very common error. I run into this error all the time. I think the important thing as programmers is not necessarily knowing how to avoid this problem, but rather recognizing it for what it is and knowing how to fix it. That's what makes a good programmer. Not avoiding problems, but having the confidence and the know-how to fix them. because problems are unavoidable. We're humans. We're going to make mistakes. We're going to write code that doesn't always work. That's a fact. But we can fix it. We can look at the problems and fix it. And so how do we do that? The computer's trying to help us out. Read the information that the computer's providing. It's really, really trying to help us out. Starting with this, array index out of bounds exception. I know that sounds very long and scary, but think about what that means. It means that the array is this long, and you try to access something over here. Out of bounds. Out of bounds, right? If we scroll over, it gives us even more information. Index 7, out of bounds for length 5. Oh, there's 5 things in the array, and you tried to access bucket number 7. That doesn't work, right? And if that's not enough, it's really, 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 really trying to help us. This right here, that 19 that comes after the colon, that's the line number where this error happened. And if you click on it, Eclipse will take you directly there. So it will take you to the location where the error occurred. Does that mean that the problem is on this line? Maybe. Sometimes the answer might be, yeah, there's a problem in this line. Sometimes the problem might start to build before, right? But it's at least going to get you in the right ballpark, and then it's up to you as a programmer to look at this line of code and say, is the problem here, or is the problem, 1 or 2 steps ahead of time? But at least you know you're in the right ballpark. So I know it can be very frustrating and perhaps intimidating to see these red error messages pop up. But as programmers, it's our job to try and understand them and use them to help us fix our problem. There's information here. It's telling us we've gone out of bounds. It's telling us the exact values we use that caused the problem, and it's telling us where the problem happened. That's a lot of useful information. Take advantage of that. Okay, so I'm making the claim that putting numbers inside those brackets is a bad idea. All right, so how should we do it then? Well, let's consider that if I have an array of length 10, I know what all the indexes are, 0 to 9. If I have an array of length 100, I know what the indexes are, 0 to 99. So instead of writing numbers in here that may or may not work, I would much rather write code that I know is going to work because I'm going to bound the index appropriately. I know the low bound and I know the high bound, so I'm going to write code that makes sure that any value I put inside those brackets is going to be within the appropriate bounds. And that brings us to the proper way, or the more proper way, I suppose, of accessing data within an array. We're going to use a loop. We're going to use a loop to help us. So our good friends, the loops from the past week's exercises can be used, actually not that example, this example, sorry, can be used to help us with this issue. Again, I want to write code that makes sure that I don't run into this problem. So in order to do that, I'll write code that makes sure that I only ever access buckets from 0 to whatever the length of my array is, right? So let's talk about that. This is a loop that does exactly that. I'd like to walk through it with you. From our discussion last week, we know that for loops have 3 parts. The first part is the initialization. You can see that I'm starting my loop variable I at 0. That makes a lot of sense, right? The first index of every array is 0. So that is a very natural place for us to start. The second part of our for loop is our termination condition. So while this is true, the loop will keep going. As soon as this becomes false, the loop will stop. And then the third part here is our update statement. So how do I want the loop variable to change? I want it to go up by 1. So think about the values that I is going to have. The length of this array is 1, 2, 3, 4, 5, right? So this array has a length of 5. I starts at 0. It counts up by 1s. So 0 is good, 1 is good, 2, 3. I get to 4. Remember, the length is 5. So 4 works. 4 is less than 5. As soon as I becomes 5, however, 5 is not less than 5. 5 less than 5 is false. And that's good, because the index of this is what? 4. If the length is 5, there is no bucket 5. If the length is 10, there is no bucket 10. The last bucket is always 1 less than that. That's why we write it this way. So what values is I going to take on? 0, 1, 2, 3, 4. That's 5 buckets. It works. Notice how we then use it within the loop. I'm not going to put the number 4 in here or the number 7 in here. I use my loop variable, I. And because of the way that I've written this loop, I know for a fact that I will properly take on all of the indices of this array. It will not go out of bounds. I've ensured it by the way I've written my for loop. This is the proper way to access data within an array. Use a loop to enforce proper bounds. I want you to notice something else about this. Let's say that later on I need to change this array for some reason. Maybe I need to add names to it. So I'll add my name and a couple other names. There's my daughter's name and my son's name, right? So I've added a few more names to this array. The length is now 8. Length is now 8. But let's think about how that affects the loop. I'm still starting at 0. That's still good because that's the first index. That's the first address. Names.length is now 8, which means that I can go all the way up to 7. As soon as it becomes 8, this statement becomes false and it'll stop. Well, the same loop works. The same loop works, right? I can prove it to you. I can run it this way with the extra names and show you that, okay, there's the array with the extra names that I added. I can come back and take those extra names out, put it back the way that it was when we first started, run this code again. Notice all I changed was the array. I did not touch the loop, and it picks up on the fact that the array has changed. Very, 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 very powerful. Very powerful. How do we do it? This part right here. That's the magic. I am writing this loop such that if the array changes in size, the loop will automatically pick up on that and go more times if it needs to or fewer times if it needs to. The bounds of the loop are based on the size of the array. A very powerful technique. I have written this for loop or some variation on it hundreds, thousands of times in my programming career. You will use this loop or some variation on it lots of times this semester, and so much more going forward in the future. It's a very, very, very common technique. Very, 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 very common tool. And just one more time, I want you to contrast that with hard coding in the size of the array here. If I just say I is less than 8, okay, maybe that works if my array is size 7, right? But if my array is anything other than size 7, this loop does not work. That's a very important point, right? I would much prefer to have this loop that'll work regardless of the size of the array, rather than to have a loop that only works if the array happens to be this specific size. That is not very useful to me. That is not nearly as useful to me as a piece of code that'll work regardless of the size of the array. And so then I'd like to show you some very common errors that you may run into when using this looping technique. If I run this program, we'll see that I want to just print out all the contents of the array, 10, 9, 8, 7. But what I get looks different. I get 9, 8, 7, and then an error. We have two examples of what are called off by 1 errors. We're actually off by 1 on both ends. Off by 1 on both ends. The first one's pretty easy to spot. We've started I at 1. The addresses don't start at 1. But as humans, that's how we've been trained for our entire lives, so it's a hard habit to break. I understand. That's why we spend a lot of time talking about it. It's important to remember that in this class, we start counting from 0. 0 is the first number we count from, not 1. So that's 1 off by 1 error, and if I run this program again, we'll see that, okay, there's the 10. 10987 error. Okay, it's telling me array index out of bounds. Index 4 out of bounds for length 4. That might seem curious. I hope it's not, though. If the length is 4, the address of the last value, the index of the last value is 3, not 4. Not 4, right? So which part of the loop is screwing us up? It's right here. I'm saying I is less than or equal to the length of the array. It should be strictly less than. Strictly less than, not less than or equal to. Some people prefer to keep the equals in there and then say this. Less than or equal to the length minus 1. It works. I think it's more typing, so that's why I prefer to just do strictly less than, but I'm not going to argue with you if this is how you see it. That's fine with me. I think the most important thing to keep in mind here is that it can never be the length. That's not going to work. Always has to stop 1 less than that. But yeah, once you fix those off by 1 errors on either side, we'll see that the code is actually going to run properly without any errors. And again, the nice thing about it too is that I can add more numbers here and the code will still work. It will still adapt to those new numbers that have been added and function appropriately without me having to change the for loop at all. It's very powerful, very useful. Any questions before we switch gears a little bit? Alrighty. So next I'm going to show you a different kind of loop. I know we talked about loops last week. I showed you for loops and while loops. I'm actually going to show you a different kind of for loop today. The reason we didn't show it to you last week is because this type of for loop works pretty much solely with collections. So we're going to be using it with arrays today. It's called a for each loop. It's called a for each loop. And what I'm about to describe to you is not necessarily a replacement for the for loops that we've been using. If you understand how this for loop works and you want to use this style of for loop in this class, then that's great. All in favor of that. But as is the case in programming, there's almost always going to be multiple ways to do the same thing. And for each loops, while they aren't strictly replacements for this style of loop, they do have their purpose. A lot of people really like them a lot and use them all the time. So let me show you an example. This is our for each loop right here. And I'll actually rewrite this in just a moment and show you how I would do this in the other style of for loop as well. But the biggest difference is that there's no index involved. There's no index here at all. So the way that a for each loop works, I would describe it a little bit differently than the style of for loops that we've been using. The style of for loops that we've been using up until now, like this one, I would say are iterating by the index of the array, starting at 0 up to the length. Whereas a for each loop would be said to iterate by value. So in the past example, my loop variable is going to go 0, 1, 2, 3, 4, all the way up to the length. With a for each loop, it is not going to do that. It's going to skip the index entirely. The first time through the loop, it's going to be 10. The second time through the loop, it's going to be 9. Third time through the loop, it's going to be 8. It takes on each value, not each index. And I can show that to you by running this code. Here we can see it's displaying the contents of the array. But let's talk about how the for each loop does it and contrast that with how we've been doing it before. A for each loop only has two parts. So when I was iterating with the index, I was using the three parts of the for loop. A for each loop only has two parts. The first part defines our loop variable. Notice that the type of the loop variable is related to the type of data that's stored in the array. That's not a coincidence. That's not an accident. I then have a colon, and then the array comes after the colon. So the way that I would read this in English, I would say for each integer value in, that's kind of what the colon represents, the high scores array. For each integer value in the high scores array, print out the value. And that's exactly what it does. So the first time that I go through this loop, value is 10. The second time I go through this loop, value is 9. Third time I go through this loop, value is 8. It's exactly what's happening. Contrast that with the style of for loop that we did just a moment ago. This is the equivalent loop that would iterate over the indexes as the for each loop directly above it. I'm making the claim, and I can show it to you here in just a moment, that this loop and this loop are going to lead to the same outcome. They do it in slightly different ways, but they lead us to the same place. The first one leaves the index out entirely. There's no index here. The second one says 0, 1, 2, 3, 4, and then plugs that index into the array. Notice there's no square brackets here, right? I don't need them. I'm leaving the index out, just iterating by value. What does this mean for you practically? So you're faced with a situation where you have an array, you feel like you probably are going to have to use a loop with the array, go through each of the values, right? Which one should you use? Should you use the for each loop, or should you use this one that uses the index to access the values? And the question is, well, the answer is, well, it kind of depends, right? Do you need the index? Do you need the index in order to do what you're trying to do? If the answer is no, then you can use a for each loop if you want to. But even if the answer is yes, you can still use this kind of loop if you want to. Right? If you absolutely have to have the index, if the index is a required piece of information that you need to accomplish the task at hand, which may be possible, then the choice is made for you. You really essentially have to do it this way. The for each loop, I think, while technically possible, would be a clunky tool to use for that job. There is not necessarily going to be a right or wrong answer. You might find yourself in a situation where either could work, and you could actually envision both approaches. Oh, I could do it this way with the for each loop, or I could do it this way with an index loop, in which case, that's up to you. One of the things that I think I would like for you to learn in this class is what your own personal coding style is, right? Some people love for each loops and they use them every chance they get. Other people hate them and avoid them like the plague. I don't really care either way. I want you to be aware of both. I think you should know how both work, but I'm not necessarily going to expect you to write them in every single situation. You have some say in that. You have some control in terms of what loops you understand the most and how you understand how to apply them to a situation. That always matters more to me than forcing you to do things in a particular way. Your understanding, your ability to apply the code that you know to solve a problem is always more important. So your own personal preference definitely matters. But it's definitely good to be aware of other ways of doing things, if for no other reason than other people are going to write these kinds of loops, whether you do or not. You may have to understand their code. So you still have to know how to do it, even if you don't necessarily plan to use it a whole lot yourself. And just for completeness sake, somebody asked me this last time, and I thought it was an interesting question. You can use a while loop to do this too, right? Here is, for completeness sake, the equivalent of the above written as a while loop. So we have the same thing happening 3 different ways: for each loop, for loop with the index, and a while loop. Notice that there is no while each loop. That's not a thing. It's called a for each loop. It's always going to be a for loop. So there is no other way of writing these while loops. That is the way to do it. Any questions? Any questions? Okay, let's take a look at another example of a for each loop then. So we're actually tasked with writing a for each loop in this case. I think this is a good example. We're given this array of values. Let's examine what we've got here first. I see a for loop here that looks like it's using the index way of iterating, right? From 0 all the way to the length of the array. What's this line of code doing? Can somebody explain what's happening inside these parentheses to me in English? What's that doing? Yeah.
Saying if the value is even.
Yes, so that is the very, 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 very short answer, which is correct, saying whether it's even. If we can explain that in more specific detail, though, I'm fetching a value out of the array. This is called the modulus operator. So that returns the remainder after division, not the actual result of division, but the remainder after division. So the way to think about this, I'm going to take the first value, 6. I'm going to divide it by 2 and say, what's the remainder? The answer is 3, right? 2 goes into 6 3 times, but I don't care about 3. Literally do not care about 3 at all. I care about the remainder. 2 goes into 6 3 times, and there's 0 left over. So that means that 6 is even, right? Because it's evenly divisible by 2. 2 divided by 2 is 1, but I don't care about the 1. I care about the fact that the remainder is 0, so 2 is also even. 1 divided by 2, a little bit of a tricky one. 1 divided by 2 is 0. 2 goes into 0. 2 goes into 1 0 times, and there is a remainder of 1. So 1 is not even. 1 is in fact an odd value. This is iterating through the loop, one value at a time, and printing out when it finds an even value. I can run it and show you that that is in fact the case. 6 is even, 2 is even, 12 is even. Skipped 1, 7, and 5. Those are all odd. So modulus tells us the remainder after division. If I divide by 2 and the remainder is 0, equals 0, that's an even number. Okay, I wish to rewrite this whole thing using a for each loop now. So I'm going to copy it and paste it down here and rewrite it, this time as a for each loop. So I'm not interested in doing the index stuff anymore. I'm interested in writing a for each loop. First part of writing a for each loop is to declare your loop variable, and the loop variable is going to have the same type as whatever is contained in the array. So it's going to be an int. I have to give it a name, call it v. Then I have a colon, and then the name of the array or collection that I am planning to iterate through. So this loop variable v, the first time through the loop, is going to have what value? 6, the first value from the array. First time through the loop, v is 6. Second time through the loop, v is 2. Third time through the loop, v is 1. So how does that change things down here? Well, before we were using the index with the square brackets to access the buckets, but I'm not looping via index anymore. I'm now looping via value. I'm iterating by value. So I can actually just do modulus directly to v, right? I don't have to plug the address in anymore and retrieve the value from the bucket. I just do it directly on the value, and then down here I could just say v as well. And I believe that should get us to our desired outcome. See, the same thing gets printed twice. This is the first loop. This is the second loop rewritten as a for each. I'm making the claim that these are identical, functionally. They do behave slightly differently in terms of how they accomplish the goal, but they get us to the same place. Again, is one more or less correct in this situation? Absolutely not. They both work just fine. I'd be happy to see you use either one. Does anybody have any questions on this example? I've got a couple loose ends I want to tie up with you before we switch to our next topic. First off, some people noticed last class that the indentation's a little weird here. Like it seems really small here and then really long here. It's inconsistent, right? And that's true. I think that this code was written on a different computer, and then this code is maybe written on my... I like my indentations really long, so the long ones are probably for me. I like long indentations. I don't like short indentations. But if you... Well, for one thing, I want to make it clear. The indentations, while useful, have no effect on how the program runs. So if I do something like this and lean on my tab key for a while, okay, that line of code is all the way over here now. There it is. Program still works exactly the same way. Computer does not care. Does not care, right? Works exactly the same way. But I care. And I hope you do too, because this is ridiculous. I think we all would agree that tabbing a line of code such that it's off to the side of the screen is not a very nice thing to do to somebody who's trying to understand your program, right? Makes it very, very difficult to see what the heck's going on. What I see in my office and in lab is usually not that extreme, right? Nobody is intentionally trying to make their code look that bad. I think what I'm more likely see is just a little bit of sloppiness, maybe you just forget to indent some, or maybe I indent a little bit too much sometimes, maybe my brackets are a little bit weird, right? So this is maybe a little bit more accurate to what I would see. This is bad. I hate this. It makes me want to cry. I can't tell what's going on here. The indentation does matter. But the good news is that you don't need to sit here and count the tabs yourself. Let me show you a little trick. Maybe some of you have already had the TAs tell you this trick. If not, they definitely will if you show up to a demo with some sloppy code. And so will I. Control A highlights the entire file, everything. And then Control I tells Eclipse to fix the indentation. If you're on a Mac, it's probably Command A, Command I, right? That is a very, 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 very useful tip. At the very, very, very least, I hope you do this before you sign up for a demo. But I think it's in your best interest to do it often, all the time. Because if your code is not indented properly, right, will it still work? Sure, but you're just making it harder on yourself to understand what's going on. You're the one that has to write this code to make it work. If you can't see where stuff is visually, it's just making it harder for you. Just making it harder for you. So please, 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 please try to keep your code clean. Use Eclipse to help you. Control A, Control I. It's almost automatic for me sometimes. If I sit down and a piece of code doesn't look quite right, I'll just hit it without even thinking about it. Please take advantage of that. Another thing that I wanted to point out real quick before I move on to what should probably be our last topic of the day. What if I just want to see the contents of an array? What if I just want to see what's in it? So I'm going to delete this code for just a second. I make an array, I put some values in it, and then I just print out the array. I just want to see what the heck's in there. Okay, that's what I got. That is not it. That is not what is in my array. I actually know what this is. This is, if you followed along with me, you probably see a different number. I would be very surprised if your numbers look exactly the same as mine. This is the memory address, the actual physical location on my computer where the array is. It's an actual physical location somewhere on my laptop that says, this is where you can find the array. That's not what we want. That is never what we want in this class. In other classes, that could potentially be useful information. In this class, we wish to see the contents of the array. Well, surprise, surprise, if you want to see the contents of the array, you got to loop it. When I say that I've written this loop so many times, right, I'm literally writing it from memory because this loop is burned into my brain. This is how we see the contents of an array. Iterate through, print out one value at a time. You cannot just say print the array. You'll get garbage. You have to say iterate through the array, print out one bucket at a time. There we go. There it is, right? It's a common trap. I can almost guarantee somebody's going to hop on Piazza later on this week and be like, trying to see what's in my array, and it keeps printing out this garbage. This is the answer. This is the answer. I've been there too. It's annoying. Have to go through and visit each value one at a time. Alrighty. Got one topic left for you today, and it's a good one. Bit of a doozy, perhaps. We're going to step it up a notch. All of the arrays that I've been talking about so far, if we were in math class, we'd probably call them vectors, right? They're one-dimensional. Are they row vectors, column vectors? I don't know. Yes, either, both. I don't know. That the direction really matters to us, but the point I'm trying to make here is that while one-dimensional vectors certainly have their uses, and we'll be using them a lot, we're not just limited to one dimension. It is entirely possible for me to have multi-dimensional arrays, so we're going to bump it up to 2 dimensions. Bump it up to 2 dimensions. So what does that look like? What does that mean? If one dimension is a row, or a column, I guess, depending on how you want to think about it, if I'm dealing with 2 dimensions, I now have a grid, a rectangle, right? A rectangle. And with that rectangle comes rows and columns. Both have both rows and columns, right? It's 2-dimensional, 2-dimensional space. I now have a grid, a rectangle of buckets, a rectangle of buckets. So how do we create and use 2-dimensional arrays? Well, take a look at how many sets of brackets I have there, right? That's saying that I'm creating a 2-dimensional array. It's even more important to understand when dealing with a 2-dimensional array, they come in what's called row major order, meaning that the row comes first and the column comes second. So the first set of brackets here represents the rows, The second set of brackets here represents the columns, which really is more important when I look over on this side. I'm creating a brand new array that has 2 rows and 3 columns. That's 6 buckets total, right? 2 rows, 3 columns each. 2 dimensions. 2 dimensions. Now we have to think about how that changes everything else that we've done with arrays. How do I access values in a 2-dimensional array? One index isn't good enough. I now have rows and columns. How do I know how many rows and columns an array has? Well, let's talk about that. That's what's up here on the screen right now. When I say array.length, if that's a 1-dimensional array, and I say .length, then that's just the size of the array, right? That's how many things it has. But now I've got 2 dimensions. So if I have a 2-dimensional array and I say, tell me the length, that is going to be the number of rows. That is going to tell me the number of rows. So then the question is, okay, how do I get the number of columns? That's a little bit tricky. You can see the code for it right here, but let me explain exactly what's happening. I'm saying, go to row number 0 and take the length of that. The length of one of the rows is the number of columns. However, we're making some assumptions, right? And I want to talk about those assumptions. When I say that, first off, I'm assuming that there is a row 0. Well, if there are, less than 1 rows, then the array is non-existent, right? It's like a black hole or something, I don't know, right? So we're assuming there's at least 1 row. If there is not at least 1 row for us to take the length of, then it's not a 2-dimensional array. That's what I would argue. We're also assuming that all of the rows are going to have the same length, or in other words, we're assuming that this is in fact a rectangle. And I want to be clear with you that in this class that will be true. I will not show you any 2-dimensional arrays that are not rectangles. In real life, however, that does not have to be true. You absolutely can run into 2-dimensional arrays that have differing length rows. They are not rectangular in shape, but you don't have to worry about that in this class. That's a problem for a different class. The short version of what I'm showing you up here right now is that dot length tells me the number of rows, but in order to get the number of columns, I have to take the length of the first row. So if I run this program now, you can see it tells me 2 rows and 3 columns. If I change these numbers to something else, right, this should be 7 rows and 5 columns. That's what I would hope. 7 rows, 5 columns. Okay. So we've got these 2-dimensional arrays. Actually, one other little side tangent that I'm not going to make you do in this class, but I still think it's important for you to know. Why stop at 2? Right? Can I do 3-dimensional arrays? Absolutely. Absolutely, I can do 3-dimensional arrays in 3-dimensional space. We are not going to do that in this class. We're going to stop at 2. Oh, but wait a second. Why stop at 3? Do you think the computer cares about our 3 dimensions? It doesn't. How many dimensions can I put onto an array? How many do you want? Computer doesn't care. Is this potentially useful? Yes. Have I ever seen an array with this many dimensions? No. No, I have not. Have I seen arrays with 4 and 5 dimensions? Yes. Absolutely I have. Absolutely I have. It's not the easiest thing for our puny human brains to think about, but the computer don't care. Not one bit. We're going to stick to 2 in this class, though. No more than 2. I promise. I promise. No more than 2 in this class. Unless you want to. You can come make an appointment with me in my office and we can go wild with as many dimensions as you want. But I'm not going to ask you to do anything more than 2. All right. Let's talk about how we can use these 2-dimensional arrays Here, I'm actually going to condense. I don't know why they split the declaration off from the rest of it. I prefer to do it all in one go, which is why I'm fixing this code right now, because it's bothering me a little bit. But yeah. Okay. I'm creating two arrays here. I'm creating a two-dimensional integer array that has 2 rows and 3 columns, and I'm also creating another one that has 3 rows and 2 columns, right? But, okay, if I want to put a value into that array, I have to specify a full, complete address, which is now 2 indices, a row and a column. And remember, row always comes first. So I'm saying, take the value of 15, put it in row 0, column 0. Take the value of 10, put it in row 0, column 1. What does that look like? Well, I'm going to bring up my fancy MS Paint drawing that I just did from the last section, right? Here I have an array, a two-dimensional array that has 2 rows. This is the first row, or row 0. You can see that this is the second row, or row 1, right? So 0, 0, that's my top left corner. Row 0, column 0, top left corner. If I scooch over to this spot, I'm in the same row as before, row 0. I'm now in column number 1. And if I scooch over here, that would be 0, comma 2, right? Row 0, column 2. And then this is row number 1. So this would be 1, comma 0, 1, comma 1. You can see I have the last one marked down here as 1, comma 2. Notice that the same properties are true as were for one-dimensional arrays. If I have 2 rows, that's row 0 and row 1. There is no row 2, right? Row 0, row 1. If I have 3 columns, I have column 0, column 1, column 2. There is no column 3. There are 3 columns total, but the last one is column number 2 because we start counting from 0. Everybody with me? Yeah? So with that information, we can now specify all of the positions that we want to in our arrays. But as I've already, kind of explained, I don't like doing things this way because if the array changes sizes, then these numbers may no longer work. I don't like doing things that way. I like using loops to ensure that my values, my bounds, will be enforced. And that if the array changes size, then the loop will automatically adjust to that fact. And so let's talk about 2D array traversal. That's going to be our last example for the day. A couple of interesting things to talk about here. For one, actually right up here at the top, there's our good friend, the curly brace syntax again. So if I know what I want my two-dimensional array to look like, I can use the curly brace syntax. You can see the rows. I've actually tried to format it very intentionally. You can see the first row contains 1, 2, 3. The second row contains 4, 5, 6. Right? So this value right here, that's position 0, 0. 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Right? So just like we saw with before, we can do either way to fill our arrays, with the curly bracket syntax or filling it up after the fact. What I would like to do now, though, is walk through this loop structure down here. You'll notice that I have a two-dimensional array, and in order to traverse that two-dimensional array, I now have 2 loops. That's not a coincidence. The first loop is used to control the bounds for the row that I'm currently on. The second loop is used to control the bounds for the column that I'm currently on. If I had a 3-dimensional array, I would have a third loop here to match that dimension, right? 1 loop per dimension. That's a pretty straightforward, pretty standard rule. Notice that this loop is inside of this loop. What do we call that when it's inside? Nested. And that has some effects on how this loop runs. So what I would like to spend the remaining time doing today is showing you this code in the debugger. I'm a big fan of walking through code in the debugger. You can see I actually already have my breakpoint set from when I did this the last class. I've got my breakpoint set over here on line 12, right? And I would like to show you how we're going to go through this two-dimensional array. So I'll start it up in debug mode. Here I am on line number 12, getting ready to start my first for loop. The array is created, and you can actually see the array up here. And if you want to expand the array in the debugger, it'll actually show you here's the contents of row 0, here's the contents of row 1. That can be useful. Although you can imagine that if I have an array with 10,000 things in it, this becomes very hard to use very quickly, right? For small arrays, though, not entirely a bad idea to use the debugger to take a peek. What I'm more interested in, though, are the loop variables. I have one called row. Notice that row is going from 0 to the length. That's the number of rows. And then notice that column is also starting at 0 and going to, that's the expression that we said tells us the number of columns, right? So let's walk through this one step at a time. I can see that row starts at 0. I'm now entering in the nested for loop. Column starts at 0. So the first value that I'm going to pick out is 0, 0, top left corner. Okay. It extracts that value from the array using the bracket syntax. Notice I'm using the loop variables, row and column, inside of these brackets, right? So I grabbed the value at 0, 0, which is 1. Looks like I don't actually care about the math for this. I think it's computing an average or something. I really don't care. I'm more interested in the motion of these loops. And so now, because this loop is inside of this loop, remember that we're going to finish this entire loop first. So row is going to stay constant, and my column is going to go up 1. So column becomes 1, row is still 0. The next value that I'm looking at is this one right here. Top middle, right? I step through, I grab that value out of the array, and I add it in. Row remains constant, column now becomes 2. So what am I doing? I'm starting in the top left, and I'm going down the rows, left to right, just like I'm reading a book. Just like I'm reading a book. Start at the top left corner, go all the way down to the row. Once I'm finished with that row, I'm going to bump down to the next row and go all the way down that row. So let's watch that in action. This loop should be finished now. Column is 2. It'll go up to 3, which will make the condition false, and exit this loop, right? But this loop is not done yet. So even though the inner loop has finished its job, the outer loop is now going to increment my row. There it is. Row is now 1. And I'm going to run this whole inner loop all over again. Column's going to start at 0. I'm now looking at the value of position 1, 0, which is this bottom left corner right here. If I continue to step through, we'll see that the row remains constant while the column bumps up to 1. That gets me the middle bottom. And then finally, one last trip through this loop gets me 1, 2. That's the bottom right-hand corner. At this point in time, both of my loops are done. This loop finished the second row, and there are no more rows for us to process at this point. So if I keep stepping, we'll see that loop's finished, that loop is finished, and I'm now down here at the bottom. It's going to compute the average and print out the... I don't care about the math. That's not the point of this exercise. I'm more interested in the pattern, the motion that we're taking through this two-dimensional array. Just like we saw for a one-dimensional array, if I'm faced with a two-dimensional array and I want to visit each bucket, each value, my brain is just going to crank this out. Boom. That's how I iterate through two-dimensional arrays. That being said, we can always tailor this. What if I don't want to go through this way? What if I wanted to go down the columns instead? Could you do that? Yeah. Anybody know how? How would I do that if I wanted to go down the columns instead of across the rows? What effect would that have on my code? Yeah. Switch the loops. Switch the loops. Think about it. This one holds steady while this one changes rapidly. So rows held constant while column counts up. That's how I move across the rows. If I want to move down the columns, then I have to hold the column constant while I move the row up. So that means that this becomes my column loop and this becomes my row loop. Do you see that? See that how it changed the motion? In both cases, however, I am guaranteed to visit every single bucket. And I think that's important to understand as well. Both of these, whether I go across the rows or down the columns, guaranteed to hit every single spot. And if I don't want to hit every single spot, let's say I want to start at row number 7, that's totally fine. I can change the code to start at row number 7, right? That's also a thing that can be done. So while I'm showing you some of the more common ways that we iterate through these arrays, the reality is that as programmers, we can use those loops and make just about any pattern that we possibly want to. Do you want to go down the diagonals? Okay, you can write loops to make that happen. Totally possible. Not common, not very common, but doable. Alrighty. I think that's going to wrap it up. I think we've gone about as far as I need to for today. I did record this, so keep an eye out for that recording to go up.